Hi everyone, today we are going to look at how to solve a Sturm-Lioville problem. Okay, Sturm-Lioville problem can be defined as Px y prime plus qxy plus lambda omega xy equals to 0. This is the standard form. Okay, and then the boundary condition is given by alpha ya plus beta y prime x equals to 0 and gamma yb plus delta y prime b equals to 0. Okay, this is the boundary condition. Okay, there are two types of Sturm-Lioville theory, so we will call it normally SLP. Okay, Sturm-Lioville problem. Okay, but there are two types. Okay, one type is the regular SLP, and the other one is singular SLP. The regular SLP are defined at the interval AB. Okay, we call it finite. Now, for the singular, the interval can be semi-infinite, or infinite region. Okay, this is a singular SLP. Okay, so we want to look at this problem because there are so many problems here that can be solved using SLT, Sturm-Lioville theory. Okay, we're going to look at it later. Okay, the first thing that we want to study now on how to write as the standard form SLP. Okay, the idea is very easy. So if you look at here, if let's say I'm given example this second order. Okay, this is the second order. Now how can I write this in the standard form? Okay, so if you recall, first we need to find the integrating factor. Okay, let's say sigma is the integrating factor. Okay, what is Px? Given by minus 2 dx, and integrating this will give me minus 2x plus c, but we're not going to write the constant here. Now multiply equation 1 with the integrating factor. You have e minus 2x y double prime minus 2e negative 2x y prime plus lambda e negative 2x y equals to 0. Now this thing here, I can write as e negative 2x y prime y. I mean, you have learned this, solving first order using integrating factor, but now the difference is we are using second order. Okay, and this one here plus lambda e negative 2x y. Okay, again, how to define this here? If I use a product rule to differentiate this second time, this is what I have. Get back the same thing. Okay, now if you compare to this one with the standard form that I wrote earlier on, where the standard form is given by Px y prime y plus qxy plus lambda omega xy equals to 0, we can see that my Px is e negative 2x, my qx is equals to 0, and then my omega x equals to e negative 2x. Okay, so this is what we get by comparison. Okay, so this is how you write second order 2n SLP form. Okay, the other thing we wanna find is the eigenvalue and eigenfunction. Okay, for this equation. Okay, so consider the same. Consider another problem now. Let's look at another problem. Okay, we want to study the eigenfunction and eigenvalue. Okay, there are a few things we can determine. Let's say for a given problem, y double prime plus lambda y equals to 0, where x is defined from 0 to 1, y0 minus 2y prime 0 equals to 0, and y1 equals to 0. Now, first thing that we must make sure this is in the form of Sturm Lioville. Okay, and then next time is we want to determine the sign. The sign of lambda, where lambda is the eigenvalue. So to determine the sign of lambda, we use something called as the Rayleigh Quotient. Okay, the sign can be determined by Rayleigh Quotient. The Rayleigh Quotient is given by this: lambda equals to negative y px y prime from a to b plus a over b px y prime squared minus qx y2 dx over ab omega x y squared dx. Now this equation can be very scary, but we're not going to solve this. We just want to determine the sign. Now this equation, Rayleigh Quotient, is referring to the standard form of your SLP, which is given by this plus qxy plus lambda omega xy equals to 0. So in order to use this, you must make sure the given equation in the standard form. Okay, so what we need to do here, we just need to check the numerator. This is the numerator, to see that whether the numerator gives you greater than 0. If numerator greater than 0, then your lambda will be greater than 0. If the numerator less than 0, then lambda will be less than 0. Okay, don't worry about your denominator. This denominator will always be greater than 0, since our omega x here is greater than 0, that defined on the interval a, b. Okay, let's consider one example. Okay, so the same problem that we have y double prime plus lambda y equals to 0, where my x from 0 to 1, y0 minus 2y prime 0, this is the condition given, and the other boundary condition is given by this. Okay, so by comparison to the standard form, compare this with this, we know my px is 1, my qx is 0, and omega x is 1. Okay, and the interval a equals to 0, b equals to 1. Okay, this is my A, this is my B. Okay, now putting into this Rayleigh equation, okay, what is the, so what we want to determine the sign of lambda. The question is very easy. Determine the sign of lambda, which is the eigenvalue. Okay, so we need to use Rayleigh quotient, where Rayleigh quotient is given by, I'm going to write it back, y px y prime from a to b plus ab px y prime squared minus qx y2 dx over ab omega x y squared dx. Okay, put whatever information we know into this equation. We have y prime, because my px is 1, from a to b plus from a to b px, which is 1, so we have y prime squared minus q is 0 over a to b omega x is 1, which is just left us with y squared dx. Okay, now simplifying this equation here with the interval AB, 0 to 1 plus 0 to 1, y prime squared minus 0, I don't have to write the minus 0, over 0, 1, y2 dx. Now to determine the sign of the lambda, we just focus on this part here. Okay, the numerator. Focus on your numerator. Okay, now if you look at this, if I put this value here, okay, putting on 1, so I have minus y1 y prime 1 minus y0 y prime 0. Okay, that's all I need to consider. This thing here, you don't have to worry because it will always be positive. Okay, this will always be this part here, y prime squared integrate from 0 to 1 will always be greater than 0. So we don't have to worry about that. We don't have to look at the denominator. We just focus on this one. Okay, negative. What is y1? The initial condition. Back to the initial condition given, where y1 is 0. Okay, y prime 0 is whatever this minus this. Okay, so we have y1 is 0, 0 minus with y0 y prime 0. Okay, now y0, according to y0, it's given y0 minus 2 y prime 0 equals to 0. Okay, so what is y0? Negative 2 y prime 0. Okay, so y0 over 2 will be negative. Positive here, sorry, positive, because I bring it over here. So I have, this is y prime 0. So putting into here, we have negative y0, which is y0 over 2, which is this one. Okay, y0. So we have negative y0, and y prime 0 will be y0 over 2. Okay, so positive here. So we have half y0 squared, which will always be greater than 0.